You know, there's this invisible force at play all around us. It's in the brakes of your car, it's in the massive machinery that builds our cities, it's everywhere. We're talking about pneumatics and its liquid-based cousin, hydraulics. Today, we're going to pull back the curtain and see just how this simple yet incredibly powerful technology works and why it's really a hidden giant in our modern world.
So, let's just start with a puzzle. How on earth could you lift an entire car with just one hand? I know it sounds completely impossible, right? Something a superhero would do. But it's not magic, it is pure, beautiful science.
The secret is something called fluid power. The whole idea, as you can see right here, is using a confined fluid, could be oil, could even be air, to literally multiply force. A tiny, easy push on one end creates a massive, powerful lift on the other.
Okay, so what is this stuff really? To get it, we need to understand what's actually happening inside all those pipes and tubes. So let's break it down. At its core, fluid power is really just a way to move energy from point A to point B. You start with something like an electric motor. That motor drives a pump, which puts a fluid under a whole lot of pressure. Then, that pressurized fluid zips through some pipes to something called an actuator. And that's what does the actual work, like lifting that car.
So how does that force multiplication thing actually happen? I mean, how do you get more out than you put in? Well, the secret sauce is a fundamental law of physics. This is really the magic behind the whole machine, and believe it or not, it's incredibly simple.
It's called Pascal's law. And here's the key takeaway. When you put pressure on a fluid that's trapped in a sealed system, that pressure doesn't just go one way. It pushes out equally, in all directions, all at the exact same time.
And here is where that law turns into raw power. See, pressure is just force divided by area. That means a small force pushing on a small area can generate the exact same amount of pressure as a gigantic force pushing on a huge area. That right there, that's the whole trick.
So you can think of it like a tale of two pistons. On one side, you apply a small, easy-peasy force to a small piston. But because of Pascal's law, on the other side, the system delivers a massive, super powerful force from a much larger piston. It's the same pressure, but you get a totally different result. That's force multiplication.
All right, now that we've got the physics down, we can basically build a fluid power system from scratch. The easiest way to think about it is like the human body. It needs a heart, a brain, and muscles. So let's start with the heart, the part that gets everything going.
Absolutely everything in one of these systems kicks off with pressure. You can almost picture it like water building up behind a dam. It's just pure potential energy, the lifeblood of the whole operation, waiting to be unleashed.
So, how do we make that pressure? Well, like we said, it depends on what fluid you're using. For pneumatic systems that run on air, you use a compressor. For hydraulic systems running on a liquid like oil, you use a pump. These are the heart of the system, creating that initial pressure that drives everything else.
Okay, so we've got our power source. Our heart is pumping. But a heart without a brain is, well, it's just chaos. You need a way to control and direct all that power with some real precision. You need the brains of the operation.
I mean, think about it. You don't want a giant construction arm just swinging around wildly, or the brakes on your car just slamming on whenever they feel like it. You've got to tell that pressurized fluid exactly where to go, when to go there, and how much force it needs to deliver when it arrives. And that is the job of valves, just like the one you see here. They are the brains of the system. They're constantly opening and closing, acting like little switches or traffic cops, directing the flow of that fluid to the exact right place at the exact right time. So we've got our heart creating the power, we've got our brain directing it, but what's the point of all that if nothing actually moves? The final piece of the puzzle is the part that does all the heavy lifting. We need the muscle. This is the moment of truth. This is where all that pent-up energy that's been stored in the fluid finally gets converted into useful mechanical work. Real, actual motion that can push or pull or lift or turn something in the real world. These muscles are called actuators, and they usually come in two main flavors. On the left, you see a cylinder, which turns that pressure into straight line or linear motion, perfect for pushing and pulling. And on the right, you have a motor, which creates rotational motion for spinning things around. And there it is, the whole picture. At the very bottom, you have the energy supply, the heart making the power. In the middle, you've got the control elements, the brains directing the flow. And right at the top, the working elements, the muscle, do the actual job. Heart, brains, muscle. It's a complete and really elegant system.
It's a really cool design for sure, but what's the payoff? Why go through all this trouble with pumps and valves and fluids? What are the actual real-world advantages of doing things this way?
Well, the benefits are just huge. Fluid power systems let you massively increase your output, and with incredible accuracy. They cut down on wasted materials, and they reduce human error. But most importantly, they take a huge physical strain off of human operators. This lets people use their minds for more complex tasks instead of just doing back-breaking manual labor. It's all about working smarter, not harder.
So, the secret's out. This hidden power is quietly working all around you. On construction sites, inside airplanes, maybe even in the office chair you're sitting on. Now that you know the secret, the heart, the brains, and the muscle, the only question left is, where are you going to see it at work next?
Let's study more and like, share, and subscribe for such more content. And comment something you want to learn.